it's hard to go last, but it's also a little bit fun to go last, at least for today anyway. One, we've been mentioned a lot, so some people get to steal a little bit of my thunder, I think. But the other piece is you get to go have beer after this. So if I want to like put all these things in your head that I want you to discuss over a beer amongst friends, and you can throw as many stones as you'd like at me, because I lost my feelings a long time ago. And I hope that all of you will have interesting questions, because that's really what all this is about, is getting together, having a conversation, finding common ground, discussing the uncommon ground. And I think it makes us all better. So I've got what I believe is probably one of the coolest jobs in the world. I work for a great company. UL, that great company, said, you know what, we've got our roots in the fire service. We started in the fire service in the late 1800s. And instead of going and being a private company for profit and selling all of our stock to shareholders, we're going to go ahead and give all of our stock to a not-for-profit parent company that has the mission of safe living and working environments for people. So my job, instead of having monetary goals, I essentially have impact goals. So my job is to go out and dedicate ourselves and my team to the mission of increasing the knowledge of the fire service, and I get measured on how well you guys say I'm doing. So if you say, hey, your stuff's being used, it's being used out there, Ricardo talked about it and everybody was talking about it, so impact, good job. That's a cool job to have. And I love the fire service. I grew up in the fire service. I think it's the greatest profession in the world, and I think that we can do better. And one of our challenges is, the way I see it, is that essentially we've got hundreds of years of firefighting with very little research support. So now that we've really jumped full in to providing research support for the fire service, everybody wants every question answered yesterday, which becomes a challenge because it's very expensive and it's very difficult to do research with the fire service. You've got a pretty complex environment that you work in, and you got a hell of a number of challenges that popped up over the last couple hundred years of firefighting, and a whole lot of beliefs, as have been talked about, that are hard to sort out because there's a lot of context, a lot of semantics and things along those lines, like Chief Harton talked about last night, that we need to work ourselves through. And I'll tell you kind of how we've been going about trying to work through these things. So we get the cool opportunity to step back and kind of look at the fire service and see it through somewhat of a neutral lens as we stand back. And I don't know what the numbers are for your country, but the reality is the numbers of fires are down by more than a half in the United States since the 1970s. We're getting better at fire prevention. We're getting better technologies. We've got smoke alarms that will tell you there's a problem before it becomes a real problem, so the fire department never really gets called. That's good. However, when we had a system that was completely based on getting better at firefighting by going to fires, and you don't go to as many fires, it's hard to get experience, and it's hard to keep pace. It becomes a major challenge. And then there's this one, which I hear all the time. No two fires are the same, which is absolutely accurate. That is 100% true. But if we think that there is not a set of rules that fire is following, that we can understand its playbook and be able to predict it and understand how we work with it, then we're selling ourselves short, because the reality is it's very predictable. And just because I can't burn every single fire doesn't mean that we can't learn a whole lot of information that'll help us on the fire ground, make us be better, more efficient, more effective. You can't go to enough fires to put all your pieces together by yourself. I don't care if you're at the busiest fire department in Sweden, at the busiest station on the busiest shift. You go to house fires, you go to apartment fires, you go to bedroom fires, you go to living room fires, you go to fires that started 30 minutes ago, you go to fires that started 3 minutes ago. You go to fast-growing fires, slow-growing fires. The reality is that's a whole lot of complexity, a whole lot of variables. And it's hard to just gain experience to understand what's going on because you're not going to go to enough. Or maybe by the time you do, it's too late, you're done. Now, how do I pass that on to the brand new recruit that's following in my footsteps so they don't have to recreate everything I had to learn till I got to this point? And that's another challenge we have is we're not the best at learning from other people's experience. Hopefully we can get better at that. Just because you can go somewhere doesn't mean you should. We've seen evolutions in materials and technologies that have done a great job at increasing the safety of the fire service, and in many cases have decreased the safety of the fire service depending on how you look at them. Things that are meant to be safety barriers and provide time become relied upon, and we constantly push things to the limits. So if we're always pushing things to the limits, where is that safety buffer? We make it go away all the time. Not very effective, not the way it's intended to be used. Experience and knowledge have to coexist. And I'll show you all kinds of slides on how I think we can make that happen. Because if you don't gain experience and you don't have knowledge, then you don't know what's happening around you, which is a really weird spot to be. And of course, you need to know the how to go with the why. Don't overlook the basics. If I say, I'm going to listen to Stefan's theory, but I'm not going to listen to Nelson show me how to do it, then it's just stupid. You've got to be able to put those things together. If you can't pull hose lines effectively, then maybe some of the fire dynamics theory doesn't matter because by the time you get there, you're in a whole different burning regime at that point maybe. It's important that we can do both, and we should never put those things against each other. You should be great at both. So, as we boil it down, see right here, the fire service can be a complex puzzle. If every one of those pieces is a little subtle nuance to your response system, it's hard. In many cases, you don't know what the picture is. You don't know what the puzzle is as you leave the firehouse. So it becomes very difficult to put all those pieces together. You're under very tough time crunches, which makes it that much harder to put the pieces together. But there's some things we can do. So I talked about this system, and many other people have talked about this system. This is how I would describe most of the world's response system. Pretty much, you've got standard operating guidelines. You take those operating guidelines, you train people on them. They take what you train them on, they apply it on incidents, see how it goes. Hopefully you have a good outcome. You critique how that outcome went. Then you go ahead and revise, get better, and feed it back into your standard operating guidelines or standard operating procedures, pending you understood what happened. Very iterative process that goes around and around in a circle over decades. And we train and we get some knowledge, we apply it to incidents and we get some experience, and we start to put some pieces together really slowly, pending that you knew what was going on to get that experience, and your training was good to give you the right knowledge and not maybe the wrong knowledge or dated knowledge. So I think we can do better. And that system causes some problems. System leaves gaps, or as I want to look at them, puzzle pieces. So puzzle pieces, if I'm really interested in what about firefighter safety, victim safety, impact on the environment, impact on property conservation, essentially all the mission-related things that everyone has in their mission statement as a fire department. You want to dial those in. You want to be as best as you can at those. But the system we just looked at, really, if you don't know fire dynamics and you don't have a common language, that other system starts to fall apart because everybody's got different context. Then we've got the tactical what-ifs. My SOP says go through the front door, but I've been dying to figure out what happens if I go through the side door. But you can't do it. When would you do it? When someone's house is on fire? Would you just try it? It's dangerous. You've got a whole another group of firefighters that are relying on a set of standard operating procedures that what you do is going to be predictable and explainable because they're working off the same playbook. The diverse work environment. If we only got to go to bedroom fires on Tuesdays at 4 a.m. in small houses with beds on fire, then we'd all be really good at dealing with that. But we don't. We go to all kinds of different fires with all different kinds of variables, and we need to understand all those. We've got conflicting experience. Well, all the senior guys told me this was going to happen, and then I went to a fire and this happened. How the heck do I make sense of that? The system doesn't let you make sense of that. So you're left wondering, or you're left searching for other people's experience. New technology and tools. How do we normally incorporate new technology and tools into the system? Well, you throw it in the firehouse and say, try it on your next call and see if it works. Or in some cases, hey, here's a new tool. Go try it out in a realistic environment. Okay, they bring it to Revinge and they put it in the steel container and they light some pallets and chipboard on fire, and maybe it works well there. Does that mean it's going to work well at the next building fire you go to? I don't know. How do you fill that gap? Combinations of tactics and timing. How close do we have to coordinate our ventilation and suppression? What if it's PPA? What if it's vertical? What if it's horizontal? How do we know that? Do we go to the concrete training building and light a few pallets on fire and that'll tell us what our timing needs to be? No, because it's going to give you a different timing and a different fuel-limited fire that is not going to behave the same way to the timing and combination of tactics in the street, in the next house fire. So the system's setting us up for failure because we can't fill these gaps. And then we've got this changing work environment piece. Is the fuel load given to us by IKEA in 1950 the same as the fuel load given to IKEA by us today? No, it evolves. And since the introduction of synthetics starting in the 1950s as plastics were being invented, it's been a constant shift from natural materials to synthetic materials, which burn very differently. Do we understand what that means to our work environment? And if all we do is gain experience, then when is that tipping point when my experience is now with synthetic materials and not with natural materials? When does that happen? How long does that take? Some departments may never get that experience. What do you do then? You're just expected to be an expert. And then these health implications. Cancer in the fire service is really starting to get a lot of attention. How do we solve the cancer problem? By going to fires. How do we understand it? How do we know if there's even a linkage at all? How do we know how well certain types of decon work? Well, the answer to all of these is we need to change our system and adapt our system so we can fill in those puzzle pieces. Because you can't get those puzzle pieces just by going to fires and training and iterating. First off, we need a common language. If we don't have a knowledge of fire dynamics, then we're never going to speak the same language. The best part is, as many people have mentioned, the books, for the most part, say the same thing. And they follow the same set of physical laws and chemistry. And the theory's pretty solid. So if we can all speak that same language, then when we have incidents and we go to critique, and we can talk about the stage the fire was in, and we can talk about how we predicted that the fire was going to spread, then we're actually having an intelligent conversation from the same platform. If you don't know that, then you start making up a bunch of crap. And we're really good in the fire service of making up plausible explanations for things. We've done it for a really long time. Well, what happened there? Well, young man, what you see happened there is a flash-a-majiggy. Oh, yes, sir. I've never heard of that. Well, don't worry about it. I know. I'll tell you the right way. Just follow me. Stay behind me. Problem now is that little kid that just got told about a flash-a-majiggy can go on the internet and type in flash-a-majiggy probably while the guy's standing there and be like, no, that is garbage. And now we've got a rank issue and turbulence in the fire department. And I'm not going to talk about any, I haven't solved any of those problems yet. That's much different research by much different people. And then we've got this piece of, if we can feed experience into this research box, then we can start filling in all those puzzle pieces that we didn't have answers for. So all the things that we can't solve on the fire ground, all those what ifs and implications and timing and everything else, we can try them in an environment that is not someone's emergency, that replicates your work environment, that can answer some of those questions. It takes effort, takes money, takes time, but it can be done. Ultimately, all we're talking about here is adding science to experience. That's all we're doing. In many cases, we're validating what you already know, maybe with some quantifying barriers around it. That's important. In some cases, we're highlighting things we didn't know. I haven't run a set of experiments yet where someone hasn't said, well, goddamn, I would have swore that was the opposite. Because when I was in this system and I just went to fires, it told me something different. Now that you put it into a scientific environment and recreated my reality and let me step back instead of having one point of view and let me see the whole thing inside, outside, upside down, I see exactly what happened there. Great. Now we gave you good experience. And that good experience can start feeding into your tactics and strategies. And when it doesn't quite make sense or we're not putting the pieces together, throw it back in the research box. Let's dig a little deeper. I talked about this common language. Extremely important. That baseline understanding of fire dynamics allows us to discuss tactics in context, with context being the really important word there. Then, of course, we're laying on experience makes the discussion better. If we've got a whole lot of experienced people that understand fire dynamics and are having great conversations like I find in my environment at IFIW, makes for really good, intelligent conversations that I think we all learn from. Usually doesn't turn to name calling, usually. Terminology is important. If we're talking about flashovers and backdraft and smoke cooling, it's important that we're all talking about the same thing. And of course, the fire doesn't think. This is the greatest advantage we have. I guess you could say the fire's pretty dumb because it does the same thing all the time. That's great because it breaks down. I mean, I'll hear military analogies all the time. And while we love the military and everything else, that the trouble the military has is their enemy thinks. So I'm going to do A. Enemy says, oh, I see you're doing A, I'm going to do B. Fire can't do that. It's going to follow a set of rules. So there's no reason that we should not know all the rules before we go to an incident. And it allows us to make the most out of our collective experience. And that's where I think we're making a lot of headway. So here's how some people see research. And I don't know if I've been called a Muppet or certainly I know that I've been told that I wear a white coat and have pocket protectors and look at little flames. This is how we see the research. You add rock music to anything, it gets cooler. So this is a big tactic of ours. Really good videographer and rock music. So if I took a snapshot of our last 10 studies, here's what you get. So there's common themes. Common themes are, for the most part, done at full scale. Fire is very hard to scale. Not to say it can't be done and can't be learned from. But all that does is leave question marks. And when you leave question marks, you leave gaps and you get picked apart. So we tend to do things at full scale. You'll see that we, in many cases, will do fires in laboratories, which we do for really important reasons because you can control some of the variables. If I want to know what's going to happen when there's no wind, I better be able to have an environment where there's no wind. If I want to know when there is wind, then I better be able to have a known wind source. If I want to know what's going to happen in a certain size house with a certain floor plan, I can build that floor plan and I can burn it over and over and over again. I can strip it down, build it back up, strip it down, build it back up. You want to know what happens when we use low pressure, high flow? You want to know what happens when we use high pressure, low flow? And you want to know what happens when we use CAFs? Done, we can do that over and over and over again, holding everything else identical. Does that replicate every scenario? Maybe not. Does it allow us to make intelligent comparisons that we can learn something from and figure out what other tests we want to run? Sure does. Makes it so that we can wrap our arms around what the problem is. Everything from structural collapse, floors were collapsing faster, to what are in the particles during overhaul. We would respond with the Chicago Fire Department to actual incidents and measure what their firefighters was in the gases while they were conducting overhaul. Horizontal ventilation, basement fires, solar panel systems, putting it all together with FDNY on Governor's Island, vertical vent, attic fires, positive pressure, fire attack, training fires, health implications, you name it, problem by problem, issue by issue, we've been beginning to try and answer some questions with the fire service. Even larger scale things, like going to Chicago and burning a high-rise. Hey, what happens when we take this giant-ass fan and blow it in the front door of a high-rise? What will we do to a fire on the 3rd floor? Great question, let's try. What happens when we start deploying these funny-looking thick blanket things over top of windows in high-rises? Good question. They got a high-rise, we brought some measurement equipment, they provided the staffing and the tools, and we could begin to answer some questions and try. School in Toledo. How much water would it take to put out a fully involved gymnasium fire? Good question. Let's try. First time I ever got the middle finger from an old lady was at that, her laundry was on a clothesline over this direction. Whoops. That was also where I got to coin the phrase, hey chief, this is no longer a test. And the box alarm came. Bensonville, Illinois, where they were expanding the runway for an airport, and we were able to go in and burn a whole bunch of houses looking at collapse of modern construction. So the keys here are, one, what type of structure do you want to look at? What tools do you want to look at? But you can't do this without great fire service partners, which are absolutely critical in making these things happen. So let's start looking at each one of these puzzle pieces a little bit and what we've learned. So we burned a lot of buildings, studied a lot of things, made a lot of measurements, talked to a lot of people, taken a lot of flack and also a lot of praise. What did we learn? Well, from a fire dynamics perspective, pretty simple. Fire triangle still holds pretty well. The trick, like Ricardo mentioned, is can you apply that fire triangle dynamically during an event? A lot harder than it may appear. And then, of course, smoke is fuel. Getting past the idea of burning items and going to three-dimensional fuels is hard to grasp. And it's been a challenge to get that point across. Going from items burning to compartment fires, start learning things that have been known for a long time and just replicating them over and over again. Fire growth in a compartment's a function of those things. If you understand those things, and you understand their impact individually, and you understand their impact in combination, and you have a compartment fire or a series of compartment fires, you can make a whole lot of sense of what you're seeing in front of you if you understand the impact of each one of those things. And then there's essentially the model. Now we put that compartment in a structure. That compartment's in a structure, and we need to understand the difference of a fuel-controlled model and a ventilation-controlled model. If you understand which one you have, or if you default to the correct one in your operations and in your size up, then you can be much more effective. And we can get into any one of these in 1 hour detail if you'd like. The other puzzle piece is this changing fire environment piece. And in the US, we've had a number of interesting evolutions, and I'm sure you all have some interesting evolutions in your environment as well. First one's larger homes. I mean, I come over here and I'm like, man, I wish I could fight fire in that simple little box. And the average square footage of a home in the United States is up to 2,600 square feet, which is, Ed, how many square meters is that? 260. 260 square meters is average. We just had a firefighter die in a basement fire really close to our office in Howard County, Maryland. That house was 7,400 square feet. And it was so complex that it was hard to say what side was A, B, C, and D, because it bent and turned and made all kinds of different shapes that did not fit the model that we would all have on our command board. It wasn't a rectangle. Caused some confusion and might have been a contributing factor. Open spaces. This is another one. Fire protection engineers have said how important compartmentation is since the beginning of fire protection engineering knowledge. And what we do in our homes is the opposite of what we do in our commercial buildings, is that we open them all up. We remove all the walls. We want these big wide open spaces. It's not uncommon to have living rooms in houses that kind of look like this. Not uncommon at all. Different than fighting a fire in a 12 by 12 room with compartmentation. Evolving fuel loads. We talked about the synthetics dominating the environment. Void spaces. We're now using these geometries of materials that are genius from a mechanical engineering and structural engineering standpoint, and not very intelligent from a fire protection engineering standpoint, because we're able to have fire spread in multiple directions in void spaces with access to a whole lot more oxygen. Changing building materials. I'm going to give you some examples of ones that we've seen even pop up very recently. And of course, new technologies. You're expected to be an expert in everything. Solar panels, wind turbines, electric vehicles, all these evolutions, no one's coming to you and saying, hey, I wonder how this is going to impact our fire service. Maybe we should really study this so we can give them the right information that they need to be safe when they respond to these emergencies. Typically, we're on the back end of that. We're playing catch up because some firefighter came in contact with this particular technology and was either confused, or the outcome wasn't good, or maybe they let the building burn down because they didn't know what to do, or they got hurt or killed because they weren't sure what was going on. You're not going to have all of these at every fire you go to, but as they evolve and as they change, we're starting to see a trend towards these things here, this faster fire propagation, shorter times to flashover, rapid changes in fire dynamics, shorter escape times, shorter times to collapse, and really hazards that we don't know what to do with. So as these things evolve, you can't learn about these fast enough by going to fires. This is where we need that other piece, that research to help fill that puzzle piece so you're not surprised. You should never have to be surprised. It's not fair to you. Here's an interesting one we found by accident. We needed chairs for an experiment we were going to do, so we went onto an internet website and we needed them in a couple days, so we ordered a couple of these chairs right here. Look like a pretty average chair that you would have in a living room. And it shows up, and all right, we got our chair, unbox the chair. Man, this box feels light. This is interesting. So you open it up, and okay, we got polyurethane foam wrapped on the arms. And where's the wood frame at? Huh. Well, we burned it. Where the hell's the chair? I thought there was a chair here. What the heck is going on? Well, that's essentially expanded polystyrene foam. It's styrofoam with a little wood U on the bottom and a little wood U on the seat. Otherwise, you would never know a chair was there. Produces about 800 kilowatts to a megawatt. Nice little fire source. But it was one of these things where, well, why is this coming into your work environment? Think about it. Really simple. If you're going to buy furniture on the internet, what's the major cost of getting that to you? Shipping costs, right? So if it's heavy, the heavier it is, the harder and more it cost to get it to you. So if I can make it lighter, make it cheaper, you're happy, I'll pass that savings on to you. And oh, if you live in the 5th floor of a building with no elevator, you can carry it up, no problem. It's actually pretty genius in how it's designed, in that it's got some strings on the arms that actually give the arms some pretty solid rigidity. You sit in this and it's comfortable. You're not going to break the arm off as you sit down. It's actually pretty robust. But now we're burning a giant hunk of polystyrene instead of a wood frame chair. Changes your work environment. Here's a couple other quick ones. We ordered cement board. I expect cement board to be cement. Except cement board is too heavy, so let's make it lighter. So we'll go ahead and we'll fill it with those same expanded polystyrene pellets. Still really good underneath tile, easier to install, does the same thing. But guess what? How do you think that's going to off-gas and fail versus just a solid sheet of cement board? Changes the work environment. And in many cases has health implications as well, as this is smoldering in the walls. We also have energy efficiency issues. So we solve those energy efficiency issues again with polystyrene insulation board. It does a phenomenal job at increasing the insulative value of our walls, which saves energy. Except when you get a fire on the outside of a house, you now have vinyl over polystyrene right into the structure. Then the engineered lumber, where we got really smart with geometry and got rid of our mass because we were running out of trees. I think we heavily rely on Canada for trees now because we cut all ours down. But it's hard to get a dimensional piece of lumber that is of decent size anymore because we can't grow them fast enough. And then of course there's the spray foam insulation in the attic for, again, for energy efficiency, but from a fire perspective, it creates interesting fire behavior like this. So this is an attic full of foam. We start the fire in the attic with a small crib fire. This was a vertical ventilation test. So I've got a 4-foot by 4-foot hole, 1.2 meter by 1.2 meter hole with a 5/8 100-pound piece of wood hinged on top of the roof. There's some pressure sensors in there. Watch this fire behavior. It's bouncing that heavy piece of wood off the roof to get enough fuel out to release the energy with the pressure created. And then what? Can't get enough air in through the eaves, fire goes out. So what if so here we kind of had a pressure relief valve, not on purpose, but almost by design. What would happen if you got there and you had some smoke coming out of the eave line and you go in and you open it up with a hook and you introduce that oxygen? What do you think that would look like coming down into a big volume? Concerning. So now we've got this new technology and tool piece here, where essentially you're experts in everything whether you like it or not, because that's what's expected of you. So if you show up and you've got this integrated solar system into the roof and that fire gets into that integrated solar system, what do you do about it? What are the hazards? Electrical shock, right? And DC power. You have concerns about putting water on that or operating below that? You should. I mean, 600 to 1,000 volts DC is no joke. That's like grab on, never let go voltage. Very scary. Do you know how close you can be to that and flow water? Do you know what type of stream you should use to flow water on that? Should you let the house burn down? Should you let the building burn down? Pretty much what we found was as long as you use a broken stream, fog. 7 bar, you can, yeah, 7 bar fog. As long as you have an open pattern and create those droplets, a fog, then electricity will not come back through that stream. That's just one hazard to begin to put water on it. There's many other hazards as you operate around this, and we've got a study that goes into a lot of those issues. And then the other thing is fire department tools. These fans got introduced at least into the American fire service in the 1980s. We're releasing a study in 2012 or 14 or somewhere in that ballpark when we finished this study. And we were learning things that the experienced people that had been using it since the 1980s were surprised by, because they never got to evaluate it in an environment where they could stand back and look at what was happening with the fire dynamics. So it shows you, oh, just throw that on the engine and try it out. And many houses maybe are not standing because of that, and firefighters are injured because of that, and maybe houses are saved because of that. Bottom line is, you shouldn't have to guess on the fire ground. Suppression, ventilation, and timing. I asked Stefan for 4 more hours. He said no, and otherwise I'd get into all of these in a whole lot of detail. I will tell you where to go into these in all different kind of detail. But ultimately, combination of tactics and timing is critical to your operations. What do you know about that? What if you have 2? What if you have 4? What if you have 6 people? In my reality, where I came up through the fire service, we could probably put at least 50 people on the fire ground in about 8 minutes. Coordination was hard. And in some cases, we put fires out by stuffing enough people with Nomex into the structure until there was no more oxygen left. We just didn't know that's what was happening. It was genius, we just didn't know it. And in many cases, you have 4 hand lines coming from 4 different directions. Somebody was going to put water on the fire. Sometimes ventilation got ahead, sometimes it didn't, but there was always water coming from some direction to begin to make the problem go away. Today, that same department understands a lot more about the combination of tactics and timing of tactics, and is having very good results on the fire ground. In many cases, not doing much different, but just understanding better what's going on as they do those things in a very quick and coordinated manner. Basement fires, where we have found combinations of tactics and timing are as critical as any type of fire that will be fought, for what is now very obvious reasons. I mean, we've had firefighters lost and injured and surprised, typically by 1 of 2 things. They either fall through into the basement, or they get in the flow path between the basement fire and their attack point, which commonly would be the front door over top of the basement fire to go down to the basement fire. In many cases, there were other options available, like a walkout basement or windows on the side or whatever the case may be. Again, several other studies, but this is absolutely where combining tactics was critical. Because if someone's on the first floor and someone vented the basement to help them and created a flow path from the basement up through the first floor and out the front door, there's no amount of water that they could flow to stop that from happening, and bad things are still occurring on the fire ground. Now we've got the health implications, another puzzle piece I want to talk about real quick. As we look at products of combustion, and you start looking at kind of ideal models, you go from methane, and we look at how much carbon monoxide, how much soot, and how many unburned hydrocarbons are created, kind of a measurement of complete combustion. And under the same conditions, on a mass per mass basis, as you move from red oak to polystyrene, you get 15 times the CO production, 11 times the soot production, and 14 times the unburned hydrocarbon production. And if you look at particulates, for a given particle size, synthetic materials will generate about 12.5 more particles per mass, 12.5 times more particles per mass of consumed material than wood. So what's in the air is very, very different. When we start talking about smoke and unburned fuel, very, very different. And then we need to look at 2 main issues for fire service health: sudden cardiac events, such as heart attacks, and cancer. And you start to break that down. So we know that firefighting, and we've got some analyses that said that the firefighting can be linked to increased of both of those. So firefighting, you get exposed to products of combustion and heat. You've got toxic gases and particulate. They get on your PPE, they get on your skin. The heat, the same thing. You got environmental heat, you've got heating of the PPE, and then you've got skin and core temperature, kind of passing from the environment down to the firefighter. And then they've got primary physiological responses. You got the cardiac electrical function, the vascular function and blood pressure, the blood chemistry and coagulation, breath and urine. All of these things are leading to our events, but we don't completely understand the linkage as you move from firefighting to the person to the outcome. So we start looking at recovery time when it comes to sudden cardiac events. We look at decon when it comes to getting stuff off of your PPE. We look at the impact of cleaning your skin on dermal exposure, and then we've got riding position, tactics, all very complex when it comes to understanding the outcome. You guys, we want you to live well into your retirement. Very healthy, long retirement. So what can we possibly understand about both of these things? And a lot of research is happening in both of those areas, sometimes simultaneously, where the role that we often get to play is we're able to create a consistent environment in which all of these other things can be measured by our partners at the Illinois Fire Service Institute, by NIOSH in the United States, the National Institute of Occupational Safety and Health. And with that collection of people and doctors and expertise, we're learning a lot about what you're able to do. Some of it's common sense, some of it maybe not. And as you start looking about the exposure pathways for firefighters, it becomes pretty simple. What can you do from an engineering control that pretty much understands the source through the air to the surfaces, protecting your breathing, protecting and cleaning your clothing. It gets on your hands, your clothing, your shoes, face and neck, and you start transferring it from place to place. We're trying to understand that and see what we can do as all of these new technologies come out that are promised to help you and protect you. And in many cases, we're looking to Sweden as pioneers in the area that have done some excellent analysis and some excellent things to begin to understand this problem so that we can put controls in place. And then we try and take what's been done here and other places. Canada's done some great stuff, the UK's done some great stuff, ultimately trying to build on that because there's not enough funding or experts in the area where we can all recreate each other's stuff. We got to build on each other's stuff. And the more countries and the more people that are doing it and looking, the better that research gets, the quicker you get good answers. And then there's this tactical what ifs. I spent 13 years in the fire service, gone to many a fire that I wish I had back. I wish I had a different shot at a different approach to maybe get a different outcome, maybe get a worse outcome. But ultimately, you're always left in the fire service thinking, well, what would have happened if I did something different? And you never get that opportunity. And really, the cool part about research is we can play those opportunities out. We can go, in this case, to a 2-story with a basement townhouse in New York City and look at, well, when the fire was on the 1st floor, what did it do to occupants on the 2nd floor? Well, good question. That's what the temperatures were in all of the bedrooms. This is what it looked like up there. Then the firefighters did something and then it changed. How did it change? Did it become more survivable, less survivable? Did you accomplish your mission at the end? We now have the ability to look at these things like we never have before. We've got measurement packages that we've refined over time that we call victim packages. Temperature, heat flux, gas concentration, oxygen, carbon monoxide, carbon dioxide, hydrogen cyanide we're now adding with lasers, moisture measurement we're adding with lasers. pigskin to simulate burn thickness, instrumented throughout. All of these things are because the fire service keeps asking us, what if, what if, what if, what if? And we can take the measurements to begin to answer a lot of those what ifs. And that's really, and then we need to package it in a way that you can see the what ifs. Because if I give you all of the data that went into creating that graphic, you wouldn't learn a goddamn thing. It takes us months to pour through the data with some really smart people in order to see the cause and effect relationship of many different tactics in a very complex environment. But it all starts with you guys defining the questions that we want to answer. All right, so we talked about where the research can begin to fill the gaps. Then what do you do with it? We talked about this whole SOG thing, Standard Operating Guidelines. And you all probably have them. Some of them may be written, some of them may not be written. But we've seen pretty much two early approaches to implementing the research into SOGs. One is the FDNY model, which is essentially they were part of the conducting of the research, and in many of the scenarios were built around their standard operating guidelines. So we would normally do this, so do this. Okay, well, what would happen if we didn't do that and we did this? And usually that results in options. If you encounter this type of fire, you now have an expanded playbook on what you can do because we've seen the results and they say that we like the outcome that that tactic resulted in, so we're going to go ahead and expand your playbook and let you do different things and more things depending on what you see on the scene. Home run. And then we've got the LA County Fire Department model, another huge fire department in the United States on the West Coast. They've done a lot of hard work in researching the research. They've taken everything that's out there, they've put it all in front of their people, they've poured through it and said, this is enough evidence for me, we're going to go ahead and modify our standard operating guidelines in this manner. And that's the model that most people have followed as they've looked to implement from research into SOG modifications. And then this has been a major development in progress towards a common language. You have the project that Peter initiated in Ottawa, which was a tremendous step towards creating a common language. And then the US has taken on this approach through the standards process to bring together a group of people, Peter included, to make sure that we're gaining the knowledge that he gathered from his project, and ultimately beginning to lay out a set of material with research support and experience support that could possibly go into a standard operating procedure. One of the major challenges we have in the US is we've got so many fire departments, we don't even know how many fire departments we have. I think the last count, I hear anywhere between like 27,000 and 30,000 fire departments that have somewhere between 27,000 and 30,000 standard operating procedures amongst them. And the question is, why? Are the response areas that different? Is their staffing that different? Are their theories that different? And this is an approach to try to bring those things together, to not tell people what their SOG should be, but maybe what they should consider as they form their SOGs and hopefully train their firefighters. So this is an attempt to bring a whole lot of people together and agree on pretty much one of the biggest pieces is chapter 3, definitions. If we could just agree on definitions of words, this document would be worth its weight in gold. So fire departments change their standard operating guidelines, and then what? Well, you got to approach a fire department that has now been moving in a particular direction for a really long time. And you need to start with some recruit training. You can change your recruit training. So you start at the bottom and begin to work your way up. That's one component. And we've been traveling around the United States teaching what we're calling fire dynamics boot camps all over the country, which are a 3-day interactive class that is meant to be a train the trainer program for the people that do recruit firefighter training. and also continuing education training in their departments. Then we've got in-service training, where really you need to now get to all of the other members in your department. Some places that's easy. Ed can do it in a day. Some place like FDNY could take them months to hit every person in their 12,000 person fire department or whatever they're up to now, between shifts and time off and everything else. And then how often do we need to update that and keep it going? And then, of course, there's the promotional exams. When do you have a captive audience when people have to learn what's in the books? During promotional exams. If you make it a question on the test, they will learn it. And that's one mechanism that you can use to begin to change. And then you've got this whole concept of mutual aid departments. Just because you train your department, now if you start responding across borders, how do you influence the people around you so you're all on the same sheet of music? Major challenge, but overcoming. And then how do you measure the impact? How do you know if it's actually working? And this is probably the hardest one. We've done a pilot project with Los Angeles County between 2013 and 2014. This is a period of time before the training and a period of time after the training. And essentially what they looked at in their data was that structure fires were about the same. Their property loss went down by millions, their content loss went down by a couple million, and their firefighter injuries burn injuries went down from 22 to 12. Again, short snapshot, however, the beginning of a process to continue to monitor to see if the changes you're making are delivering the outcomes that you're looking for. And in this case, that was the outcomes that they're beginning to measure and look into. To get that data for a department of that size is an unbelievable challenge, especially when it gets to firefighter burn injuries, because you're talking about medical data at this point, and to get access to that can be tough. All right, so to summarize, here's our fire research model. Got our fire service, we put it together with our fire science and engineering folks. Sometimes there's people that kind of do both. Then we've got our fire service research with the fire service together, collectively, developing the questions, doing the tests, working as one. Then we've got results come out. Take those results, and we go ahead, and they might be a peer-reviewed article if we're talking to the science community. It could be a technical report if we're talking to other researchers and we want them to be able to replicate our research. It might be a summary report if we're talking to the fire service that want to know a little bit more and they like to read. For the people that don't like to read, we make online training programs because fire behavior is very visual. You got to have videos. You got to have lots of videos. You got to be interesting. So you go ahead and make it interactive and put it online. Magazine articles, videos, blah, 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 all kinds of tools in order to get the research results out. Then there's this next layer that people have been talking about. We've got our tools that we can use to get the information out. There's instructors, and then this translator word keeps coming up. Someone that can adequately take the research results and translate them into practice and give the information that the practitioners in the field need to know. Classroom presentations are effective, hands-on training is very effective, props, train the trainer, web pages, all the way down to social media. Some people want it in a 5-hour documentary. Some people want it in a 140-character tweet. It's hard to please everybody. And it's hard to take the information that you want them to know from these things and adequately get it in these things to get to the most important piece of all of this. You. All of this falls apart without you. And why do I say you? Because you got to care. You got to want to go look. We can't force you into any of this. And then the you is so important for these reasons. You all have different response systems. You have many different SOGs. You've got different staffing. You've got different buildings. You've got different tools and equipment. You've got different training and abilities. And you're all from different geographies. I can't tell you that all of my research is going to help you in the European countries, because only you know these things. I can tell you the other things and put it all in really good context, but ultimately you have to digest it. You need to put it into your context. Some of it may fit, some of it may not fit at all. Put it to the side, get rid of it, not for me. Good job, UL, that sucks, doesn't help me at all. I'm okay with that. We've got some targeted audiences. Someday I hope that the target audience is all of you. And I love to hear what Ricardo's doing, and we'll do anything we can to help him grow that, because I believe that that is how we're going to ultimately get enough information to help. All those things hopefully find themselves on the fire ground and help you accomplish the mission that you want to accomplish. Make sense? Yes? Ultimately, the more you know, the easier it is to complete the puzzle. And John had this picture in his presentation. I said, dude, that fits my theme. I got to have that. And of course, John, like John always does, says, yeah, absolutely, take that. So if it pops up in his presentation, it's going to be better. But ultimately, if you can take all of those unknowns and turn them into knowns, you have much fewer pieces that you need to put into the puzzle once you arrive in the scene with a very dynamic thing happening in front of you, with very dynamic people and resources. And if the fire behavior part is second nature, the building construction part is second nature, all of those things you've got dialed in and you're ready to go, you've got all the knowledge, then the practice piece becomes much easier. And we can't forget about the public either. Every now and then the research points to something that is important for people beyond the fire service. And we also put a lot of effort into making sure those messages find their way to where they need to find in very interesting ways. That one video is a way that we've done it. And if you go to closeyourdoor.org, you'll be able to see a whole lot of fire service resources that can be used to educate your public on the importance of closed doors. It's very different in the US than it is many other places in the world. We like to have our doors open all the time. We don't know fire dynamics. It's very clear at this point, right? We don't know fire dynamics well enough. We need to educate our public on fire dynamics. And then there's, where's the next generation going to come from? Where's the next Stefan? Where's the next Ed? How do we fill the system back up with carols and arts? Well, we're looking at that and saying, you know what? We can make fire dynamics digestible for middle school students. So what we did is we launched an interactive program working with our education team called UL Explore Labs. UL Explore Labs essentially teaches middle school students about fire dynamics through fire investigation. It teaches them about fire, teaches them how to conduct an investigation. It takes them through a guided investigation, and then it lets them do their own investigation. There's classroom experiments that you would probably recognize. A lot of them have to do with candle experiments. We have them make a calorimeter out of a soda can, and they can tell the energy release of different Cheetos, marshmallows, things along those lines. Letting them learn by doing with hands-on. So please go to ulexplorelabs.org. This translates, for the most part, I feel, from a principal perspective to Europe very well. There's nothing really unique here to the United States. And then this is where you go and find all of our stuff if you haven't gone and found it already. ULFirefighterSafety.org is our website. Closeyourdoor.org. We've got a partner website, modernfirebehavior.com, and then all the social media channels. We're on that many of them. I don't even know what some of them are. I think there's cool pictures on that one, cool videos on those, and little snippets of knowledge on there. So please watch what we're doing. And the last piece I want to say is it's not just me. I've got an incredible team. We've been able to grow that team of really cool people. And these are the ones that directly work with me, and many more work with us through our projects from the fire service. So that's all I've got. Thank you all very much.